Good evening, ladies and gentlemen. It's Konya, and I finished my first Factorio CPU, like recently, this week, last week, Friday, Saturday, about that. So now we got a nice Wednesday, and it's about to be weekend for local reasons. Yeah, and I thought maybe I'd just show you my piece of CPU. It will be wasted if I don't. So here it is, my first Factorio CPU. It's exactly this one. I built it in a normal vanilla survival world with totally normal settings, so it's perfectly possible to do that without getting the thing destroyed by biters. And yeah, and just now I made version 2, which is basically the same thing, except that it has no belt clock, and it's a bit faster for reasons, which is setup reasons, but else it's the same thing, just a little bit rebuilt so that it looks more clean, and maybe it's easier to explain what is actually happening in here. This is a very simple, very straightforward CPU. Means it has an ALU, it has registers, it has ROM. There's no special memory else. It can branch, and yeah, that's about it. It really is as easy as that. Uses absolute jump. So that's all the special facts which someone needs to know about it. Yeah. So I think I should just explain what this does. So if you're familiar with Minecraft CPUs, they are very similar to whatever I did here. Like, the very cheapest Minecraft CPU is basically what I did here, except that in Minecraft you have another dimension, which is the bit width, and here you don't, because here you got integers as data value, because it's Factorio, and they have these like numbers there. Wait, where can I go? Here's the counter. You see it's currently stuck on instruction 15, because it's set up to do that for me. There's this instruction, so I'm just gonna delete that one so that it starts the program from scratch. And what it currently does, it's doing greatest common divider, whatever, GCD. With the numbers I forgot, and the result is obviously 6. I think I grabbed the example from Wikipedia or something. So yeah, it prints 6 nicely. It's quite fast when doing it. It's currently set to 2 Hz, which is 30 in-game ticks. So you can see when it reaches 30, the counter will go back to 0. I cannot put my pointer there. I could hold my finger on the value which changes, but that won't help you much. So this is the thing. Super easy. Time to explain. First of all, this is the ROM. The ROM has a constant combinator which contains each instruction. So each of these holds an instruction. These are all possible values. I'm gonna go over these. If you're familiar with Minecraft CPUs, you may recognize these because it's a simple 3 operand CPU with all of these instruction set parameters. So basically, which register to use as A value, which operation to perform, which register to use as B value, which immediate to set onto B. So the immediate will be converted to straight B value. Instead of register B, it's just gonna dump I in there, which is immediate. And this is register C, where it should save the output from the ALU. I do have a 0 register, means if I read from register 0, I'm gonna read 0 always. If I write to register 0, it's not gonna save anything because I don't have register 0. There's also instructions for load and store, and I have not implemented that yet because there's no need by now. Maybe later, but that could look like this here. And that's basically everything which the ALU can do, the CPU can do with data. And then we got these here, which is basically the branch control. J stands for jump, says where to jump if the condition is true. And then we got these 2 conditions, which is the first one, which is 0, and the other one is negative. Or, with other words, the MSB of the result. Basically, it's a negative check. It just does that, and these 2 are essential to do basic conditions. These are 3 states. You can either have them as, or actually it's 4 states. 0 means you will never gonna jump, and that it doesn't mean which of these. If one of 0, you're never gonna jump. If both of them are 3, you're always gonna jump. And the 2 in the middle are depending on if the flag is set or not. So 1 and 2 is if the flag is set or not for each. So you have the possibility to do whatever you want to combine in there. Works perfectly well. Okay, next step. So in this case, I'm gonna check the P. P stands for pointer, which points onto the current instruction. If that is 0, put whatever the input is onto the output line, which is the screen wire here. The next one is obviously 2, so 0, 1, 2, and so on till the end of this. This is a little error fix because I have this star here, this asterisk, which says everything. That means the P from the beginning will also swap over to the other side, and I don't want that. So I'm just gonna take everything from over here, which is 13, 14, 15, whatever, and put the negative one through the output so that it just gets eliminated. Whatever, just laminated. Anyway, as you can see, there's no P in the output. So this is the opcode currently on this pole, totally in green. As you can see, it's skipping to all the instructions really quickly and looping the program like all the time. This is just a little indicator here which takes P and puts it onto the lamps so that I can see where it is currently in the program and see if it misbehaves, jumps around like crazy. So this is the ROM, quite easy, quite straightforward. Then we got this connected to the opcode line, and you see the highlighted line here. This is the opcode, it goes everywhere. So yeah. Let's continue with the register. We got this little fellow here which transfers the C value if the clock is triggering. So this only saves on rising or whatever. Whenever the clock's clocking, then this gonna save. So yeah, clock me is the yellow signal. So it takes the C from the opcode and just dumps it into the register address where to save. On the other side, we got these. Oh, damn it. I should drink some water, but I don't have any more. So in this case, on this side is the read of the register, is dual read register. So we got A here if A is 1, and on the bottom it's if B is 1, and so on with the next one. So this is if A is 2, 3, 4, 5, and so on for B. And this will also output anything, which is kind of stupid, because I could just output D here, and this would output A. Oh, this actually outputs a lot of crap, because I'm outputting anything, and that means the whole damn opcode, which is bad. But luckily, the data which we are interested in is called DEN, or is the signal DEN. That one is the only one which get past this point. How is this even working? So, this is not very good, because this is supposed to be D, and same here. Well, I just refactored this CPU in a small mistake. It's working. I don't know how, but just let's just accept it that it's working and be happy with it. I'm gonna change it later on, just to be more safe, to know that it's done properly. Okay, the register. I designed for the CPU a little concept of how to do a bit or a memory cell. And for that, I got this, these two fellows here, and this is the actual cell. So as you can see here, the output is connected to the input, or you can't see. Anyway, I told you, so now you know. And that is just doing whatever D was, output D. And if you stick on that, you can see that the input value is always the output value, because they're connected. And this little fellow here is the blue signal. The blue signal is in charge of telling, do I have to remember or do I have to forget? And what this and what the fellow over here does, it does exactly the opposite. So if the one is if the memory cell is not equal, 1, this one is equal 1. And so if blue is 0, which is not equal 1, then it remembers, but if it's 1, it won't remember, because then the condition here is broken. So this one goes to 0 at the output. But at the same time, this one says, hey, let's take all which is here, the input, D values, and put that onto the output, so that it's here. And then the blue signal swaps to 0 again, which causes this one to say, hey, oh, there's the signal, which is whatever D, and I just remember that and store it forever. So you can basically exchange the value of this cell by just having these two components and the blue signal, or whatever control signal. The blue signal is simply generated by the combinator over here, which just checks if the register address is the correct one, which is 1 in the first case, and then it outputs one blue signal, else it doesn't. So as easy as that, I hope. So there we go. We got little RS bits, no, not bit, number cell, which stores whatever you feed it. And the red wire here is the output, which goes to the two read combinators, and that is basically just checking if it's the correct number, and then it should output D, because that is the input which gets outputted here, and then it also outputs D here at this point. Yeah, what we do next, we have to refactor D, because the ALU eats A and B as numbers A and B, because it works with A and B. So what we do here is we take the D value and just convert it to an A value. It's as trivial as that. You just add 0 and say the output is A instead of D. Yay. Okay, works. That is sent back over with this wire here back to the ALU. The ALU is super easy in terms of it's small, like not in Minecraft. But in Minecraft you make an all-in-one ALU and not a multiplexed ALU, and this is like a huge big multiplexer here. You get one instruction, one combinator, it says A, X or B, or whatever instruction you want to put there, modulo, so A mod B, and the output is always D, which is data again. So D stands for data in my thing. I actually wanted to exchange that with the signal dot at some point, but not without tools. I made most of this without tools. I actually made anything of this without tools, and that's enough already. So okay, the output is D, and then we got the multiplexer below here. So this is just outputting to the bottom, and these check if the condition, if the opcode is actually the right one, and then it outputs whatever the D input is. And the D input just comes from these combinators in the top row, so it will not output something wrong from the opcode, because they get the opcode raw over that pole. Yeah, this one is actually the output, so this one, the green one, is whatever the ALU outputs right now. Or you can see the clock signal is there too, so there we go. That's the ALU output. This one is the immediate. Okay, that's quite simple. It just takes the opcode, not the opcode, the instruction signals, and filters the I signal, adds 0 to it, and just outputs it as B value. So if you read from register B and put an immediate, these will be added, because I will both output B, and Factorio just says, oh, I got two signals, same type, I just add them, when it's on the same wire or same connector or same combinator or something. Yeah, okay, so much to the data flow. There's this big thing, or not big, this scattered, not as aesthetic as I would like it to be part. Let's do this one here first, that is the clean part. That is my branch condition checker, and the flag thing, whatever. This green wire over here is, as you can see, the output of the ALU. It goes from here over to that pole, back to the registers, and these 4 dudes here also grab the signal of the ALU output. There we go. If D is 0, that is obviously a zero check. If D is not 0, that is obviously not 0 check. And then we got, if it's smaller 0, that is a negative check. If bigger or equal 0 means not negative. So we got all 4 flags which are relevant for us over here, and then we got 3 of each kind over here. So the top ones are Z, the bottom ones are N for negative, and the top ones are Z because they're just connected to this here. The first one is if it's 2, and that means then take, this is just a simple multiplexer again, so this just passes whatever the combinator here outputs onto the output. If the Z operator or Z operator instruction value for Z is 2, if it's 1, and the top one is a little bit special because that's the 3 case, and that means always jam, and that means it just outputs a green or sign signal for everything's cool. Same symmetrical for the negation. On this side we got the condition if this sign signal is 2, basically because I want to be these flags, the 0 flags, and the negation, the negative flags, both to be true. So if I leave one of the 2, the Z or the N, on 0 in the instruction, it will never jump, because then we will only have 1 sign signal at most and not 2. So it's always required to properly create the instruction and make one of them 3 if you don't need it, but you want to jump. Okay, this fellow over here is the clock. No, it's not the clock is over here. So let's quickly go over the clock. We got a constant combinator which just outputs 1, and if I turn it off, this one will stop, because then this one stops iterating, or not iterating, incrementing. So basically, as I said before, signals of the same type will just be added together. That is what happens here. This one outputs a value, 1 gets added onto it because I'm outputting onto the same port in the combinator. So this one will by nature increment forever. To not let this go overboard, you just put a simple condition into there and say, hey, if as long as V is below 30, else don't output. Means a reset to 0 again. So you got a super easy, straightforward counter here. And whenever the value in there is 1, just output 1 yellow signal, means do the clocking. The yellow one, as I said earlier, is basically here used here in the Regs, so these will only save whenever the clock signal is 1, and then it just forwards whatever the register save register is. The other side of the clock signal is used in these 2 fellows. This is the same setup as in the register, a simple number cell, set or reset, or basically override cell, a latch. It's a latch, damn it. Okay, oh no, I swear it, demonetized. I don't even get money for this. It's just for fun. Peace. Comments below if you like that stuff, or if you hate it. Anyway, who cares? So this is the cell connected input to output. If clock is 0, if clock is not, it is 1. So take this one if it's clocking. Keep the current value if it's not clocking. The data type is P. So this does the clocking. The wire here goes to the ROM because it's the output of the PC. The program counter just goes to the ROM over there. That takes the output of the cell and just adds 1, so it's the incrementer. That one is branch unit over here. Let's just ignore that for now. So the output goes back into here, and when the clock comes, it takes the next higher number, which is generated by this one. The logic below here is just one which tries to keep the number below 16. That is mainly a debugging reason, because I don't want to to let the clock like this run all the way to the end. It just aborts at some point, and that is what this logic here does, these 5 combinators. That's just a plain add-on, as you can see. It's not even properly done, it just does its job, and that's what I need. So here we got a simple multiplexer. Basically we have the control signal, which is this pink signal. If the branching says yes, you have to branch, then this combinator is activated, which has pink is 1, and this one has pink is 0, which is the default state, so this one is the extra state. So either it takes whatever the previous value was, or it jumps to whatever the value here is, the p value. And this one over here takes the j value, which is the jump address from the operation or the instruction, and just converts it into a p value or a p signal, which then gets inserted back into the program counter. Okay, that was the speedrun of explanation how this works. Over here we got a 7-segment display, which I created ages ago, before I even knew how all this stuff worked, like as good as I know it by now. I learned a lot while building the CPU, and was quite easy actually. But okay, never mind that. So this display had been built by me ages before. It just holds all the 10 possible digits in the combinators, and each of these combinators over here, except the bottom 2, is in charge of 1 digit. And they all have a condition like digit is 7 or whatever number from 0 to 9. This is just a simple modulo and division, so nothing special about this. It's super easy expandable, except that these combinators should be on the other side. But never mind that. Anyway, display shows output, good for debugging. I saw nice and much nicer displays before, and well, yeah. Okay, I went over this. So, GCD is working. Let's just take this random thing and put it there so that it stucks there and just increments whatever is in register 15. Takes register 15, adds 1, writes to register 15. Works perfect. As you can see, it's flickering. That's maybe the only downside of whatever memory register I'm using here, because these are temporarily 0 when overwriting them. Here you can see it's flickering. That's the point when it's 0 instead of whatever value there is. That's really the only downside. And if you don't do something against it, it will flicker in the display too. Oops, I don't care. It's debugging anyway. Besides that, there are some other downsides. First of all, this is a really simple CPU. Like really simple. You cannot do much with it. There's no I/O and stuff. There's no... oh, well, there's nothing basically. It does the most basic stuff, and that's what is okay. But yeah, nothing that special. So it's not pipelined. The thing is, you can actually build CPUs in Factorio which don't even have a clock, which just flow or let the data flow. That obviously requires a lot of timing, which I'm too lazy for. But if you do it properly, you can add a clock and let the whole thing be pipelined, or even better, you make it flowing pipelined. Means I use the same components as multiple times, but this is already really fast. But I'm currently on 30 ticks, so I could basically have one instruction be processed every 2 ticks. Well, that's what pipelining is about. But okay, let's not think about that, because it would cause brain breaks. Your brain breaks if you think about it or something. Especially because you have to put register forwarding and whatever stuff is connected to pipelining, and branch prediction is like the hell on earth. But yeah, that's thing to do. And I/O would be good, but I don't really know like what type of I/O to use. I thought about building a display, so like a simple black and white display. I can compress this stuff and build a simple GPU additional to to it, but the GPU will probably be 100 times bigger than the display, just because I will put one cell in the GPU for each of these pixels, which stores its value off and on, or maybe even have buffers in there, but that will be kind of a powerful GPU for simple purposes. But if it's just about graphing stuff in here, like drawing a graph and dots and things, I think there are better ways to do that. I don't know them though. Oh well, okay, I have some in my mind. Maybe you will see them eventually when I continue this logic world. Yeah. I have been checking right before thinking about starting this video, like, what other CPUs are there in Factorio, and not many. Did I miss anything? There's something wrong with people? Where are the CPUs? So I found this one, which is a belt CPU. Okay, nice thing. Really nice, because here you're working low level, really low level. You don't have all the advantages of the logic stuff of Factorio. Then we got this one, which actually performs quicksort, which is really amazing. This is the same type, like, of logic or what not. Yeah, the same component type, like whatever I did probably. I don't know. I have not downloaded this, and there's no explanation of this. And well, this one is a known Factorian dude, and with just this is amazing. It's not like I couldn't do this, but it's like a lot of work, and I may not be able to want to invest that much time into it. Maybe, but not with vanilla Factorio. So I would use an external editor for that. But this is cool, especially the number display. I like it a lot, and I will probably develop something like this myself before downloading this world. Just to challenge myself. Then I found this one here, which is like from 2016, like it's ages old from Puriform. Well, there has not been much changes in logic since then, so it's probably still valid thing. He actually is using, as if I understood that correctly, clockless one, which just has flowing data through it. But whatever. Anyway, he has interrupts and stuff, so this might be a powerful one too. If I can download it, would be cool. There's at least some documentation in the form, whatever. Then we got another version of that one. Here's another one. This is really small, like way too small. This should be some dual thread. Okay, not core, dual thread thing. So is that, if it's dual thread, is that hyper-threading? I don't know what PIC style is, so I probably will have to download this one to analyze it. What do we have here? Oh, this one is, I like this one because, oh damn it. Okay, I like this one because of the colors. Like, you got all these blinking lamps. This is awesome. You got a lot of blinking lamps. And like, display, that's real cool. But yeah, also looks really simple. It has a main bus, by the way, which is something I preferably not use, a main bus. Yeah, so that's what I found, and that's really all I found. What the heck? Where are all the other CPUs? It's not that difficult to build CPUs. Okay, Factorio is in the first place a different type of game. So is Minecraft, but whatever. There's a CPU maniac community, and that one is not really big in Factorio, and I wonder why. I gotta say, looking at this stuff, okay, well, not this one, but this one and this one, these two, that's something. Oh wait, that's something to look for. How to do them, what is happening in there. So in looking at this, it's well, I made this in like 2-3 days at most, in hours at most, but probably most of the time just thinking. The problem is something like this, like you have like 0, 1, 2, like it goes on, and you have plenty of these, and then you messed up and you put the wrong signal in here, and you have to change it. That's horrible. So what to do? There's like some blueprint library for Java, which is good. Like you can generate signals and say, this was by the way an attempt to put the opcode, to generate the opcode, but for now I said, okay, create me a row of constant combinators, put them at position 0 to 31, so that is whatever, it generates a blueprint, and I say direction is south, and then I set the signal in the first one, which is signal D. That was just a test setup, but at this point I can just set any of these signals from whatever data structure I want. I can write an assembler which then puts the data into the constant combinator, and then I just print that one as string, and that is apparently not getting executed because there's no main here. So I'm quickly gonna add a main. So what is that? Generate ROM. So like this. There we go. So that is blueprint. Damn, nice. Let's take the blueprint. Let's import the blueprint. Import the blueprint, and there you go. You got a row of constant combinator with obviously invalid data. But yes, there are ways to do it. Anyway, what you just saw was something I have been working on, which is this fellow here. This is basically it reads blueprint, which is my old CPU or parts of my old CPU by now, and it tries to put the stuff in there. Like you see the cables, you see the sizes of it, you can zoom and scroll and stuff like that. Not really impressive by now, but what I would want to have is like, instead of an empty space, I want to have the details, like which signals go in, which signals go out, and especially I want to make it clickable so that you can change it right here inside the editor. Same pain, but much quicker access to the data. This has import, this will have export at some point. This is, by the way, substation, and this is normal poles, so that's a bit of an issue to actually get the wires connected. And as you can see, you cannot see where the wires here are actually connected to, if it's just passing by, if it's just every other red wire, so there needs to be some kind of slope. And if someone is interested to participate in this project, eventually it will be on GitHub. You can always text me about this. If I give it up, I gave it up, but I will probably not. I will probably get this a little bit more further, so they can at least decently use it. But this is not really the full potential of such a project. What would be cool is if you say, I define myself a grid, a subgrid from here, this point, to over here, and every other row I increment in a variable, and then I just say I put a signal here with count of that variable. Wouldn't that be awesome? Especially if you can just copy paste that whole thing. Like, you don't have to care about how many you add, you can just add the same pattern always and always, because it will increment the variable itself. You could even go further and say, instead of this particular signal, I put a variable signal there. So I say, I have a variable here, whatever, in a side panel or something, and I can just define, I can give it a name, and I can, whenever I want, update that signal, and it will be updated in the whole blueprint. The problem is obviously Factorio does not support that kind of editing, so it needs its own save file. But once imported, you can edit it and something like that. So that is something which I consider really handy for whenever you when you want to do addition on computational stuff. I do not intend to support inventory types for furnaces and whatever, just for the logic stuff. But well, if it's on GitHub, anyone can edit it, so there's no big problem with that. And I think I said everything which I wanted to say. I have to figure out how to put something like, I just gonna put description and table of contents in the description so that you can use that to skip. I'm not familiar with all these click elements in the video, and I don't want to get familiar with that. I don't even know how to use a video edition software. So this is always gonna be a no cut, no editing, raw video, OBS to YouTube. So, okay, I hope. Anyway, this video was informative or not, whatever. This is my version 1 CPU, or version 1.1 in this case. And maybe I'm gonna make an upgrade, and that obviously gonna end up on YouTube too. Stay tuned. You can always contact me for everything. Just leave a comment, or you comment on my YouTube channel, or just text me in any messenger. My username is always Ikonia, except on these weird Twitter and Instagram. They don't have Ikonia. That's different dudes. Anyway, just text me or whatever. Use the email I used on YouTube. Whatever. I don't care. I should change that one. Don't use that email. Use another email. I'm gonna make a contact one in the description. No, I don't. I will? No, then it gets banned. So I won't. Yeah. Okay, it's kind of 10:30 in the evening. I'm not tired yet, so I'm gonna try upload this and maybe skip through it to see if anything is horrible in the recording. But I did not mess anything up, so yeah, basically the video is over, so you can leave now. And I'm gonna just keep talking or something, I don't know. Well, yeah. Yeah, yeah. Tomorrow's ice skating. Ice skating's good. Winter may come. Whole winter ice skating. Love it. And yeah, no time for Minecraft. But for Factorio. And I know, it's just so much nicer to build like CPUs in this style because it's so easy. Like, real easy. This is no effort. You don't need to know much. And like, you're so much quicker with your progress. And then you go to Minecraft and you have to build blocks and not whole circuits. That's a bit meh. And then it's slow, then it's buggy as hell, the physics is not properly, and you don't have an awesome developer team such as Factorio behind it, but a bunch of noobs. Okay, they are skilled, but they do highly unpleasant things. Mojang, not Factorio. For Factorio dev team, good response. Mojang, bad, okay? Or whatever company that is. So it's just much more pleasant to even play the game. The feeling of playing Factorio is so much nicer than to play Minecraft, just because, you know, there's people behind it who make it better. As of now, let's just hope they won't ever mess that up by doing horrible things, which probably will happen anyway. They need to change things, but they have at least some kind of brain which keeps them from doing utter nonsense, like Mojang tends to do every now and then. But okay, enough of rant. I just love that company, both the one from the other side and the other one from the good side. So yeah. I don't know what I should do next. I need a display. I need, you know, the main problem as always is you need to put some code onto these things. Okay, the most impressive thing I saw was quicksort actually, but I don't have memory, so that I cannot perform quicksort improperly. But that is also not that impressive. Okay, he got method calls, that's cool, he got a stack for that, but whatever. Something which is really cool is always user interface. User interface is awesome because then you can see whatever stuff. I mean, at least if it's a terminal. Terminal is already cool. But for that you need a GPU which is able to draw text onto a display of sort. So I think I won't get over the point without having a GPU which can at least draw text and maybe plot pixels. So that's some kind of my next goal, if I am in the mood for that. Okay, thanks for watching. I'm really curious and I don't trust the YouTube statistics. If you saw it and you liked what you saw, thumb up. If you like it really, you leave a comment. If you watched the whole thing, you also leave a comment, because I'm impressed to be able to hear my non-stop blabbering, whatever, non-stop talking all the time. That's always cool, and yeah, and if you like the rest of my stuff, whatever, subscribe, but that's pure optional, I don't care for that stuff. But actually, just share the video. No, don't share the video. Make the video famous. No, it's not of that quality, but I'm a bit derping right now. It must be the time. I think I should really stop now, else I would talk for... Oh, we almost got 40 minutes, so that's cool. I'm gonna stop when it's 40 minutes. That is, like, soon.